Okay, we're going to get started. This room is sponsored by Rubicon. Rubicon Project has engineered the Advertising Automation Cloud, one of the largest real-time cloud and big data computing systems. The company's mission is to automate the buying and selling of advertising by offering innovative products to connect buyers and sellers globally. For more information, visit rubiconproject.com. We have an online survey. If you look on the back of your badge, or if you didn't fold it over on the card with the map that came with the badge, we'd appreciate it if you could take a moment to fill out the speaker surveys. Our next talk is Easy Big Data Workloads in the Cloud with Juju. Our speakers are Jorge Castro, Marco Ceppi, and Jose Antonio Rey. This big data talk will discuss how to use Juju to run MapReduce jobs, run simple SQL-like analytics with Hive, and analyze unstructured data analytics with Pig, and also run real-time analytics with Storm. So without further ado, I'll give you over to the guys.
Okay, am I live? Awesome, awesome. Thank you very much. The first thing I'd like to say is that the description is actually not that accurate anymore, because we were doing some really cool things with Apache BigTop last night, and we decided we're gonna show you guys some of that stuff. But we'd like to also talk about those things so you don't feel like you've been baited and switched. Okay. We actually have someone from the Apache BigTop project here. Konstantin Budnik is here, and all the stuff that we're going to show you here is just all open source software. Everything you see here is free. But let me get just a little bit of a survey of what people are doing in the audience, because big data is like, I hate that word, that term. So who's doing any of this kind of stuff like in the real world? Okay, can we just take a quick survey? What are you doing over there, you guys who raise your hands? What are you deploying? What problems are you trying to solve? Okay, information about customers. Okay, customer targeting. What else? Physics data. Okay. Healthcare. Okay. What else? Lots and lots of ads. Yeah. The only guy telling the truth here. What kind of tools? What kind of tools are you guys using? Just yell them out. Hadoop, obviously, right? Cassandra? Oh, we should show Cassandra.
We could.
Okay. All right. What else? Flume. Okay. Is that it? Elasticsearch. We'll show Elasticsearch as well. That's an easy one. I'm sorry. What? Storm? Yes. Yes. We have that. I don't know if Storm works. So.
Yes.
All right. So. We're Ubuntu. We're known as an operating system company, and people are always wondering, they're like, hey, why are you guys all into this kind of, like, I thought you guys just made the OS, right? As it turns out, as we've been talking to people and customers and our users, the OS, and I hate to say this, working at Canonical, the OS is kind of a solved problem, right? You get your instance on Amazon or Azure or bare metal, whatever, and that's great that you guys are doing that, but man, you guys really want to help me out? I really I'm having a hard time deploying Hadoop or Cassandra or Elasticsearch. And as it ends up, because we also consume these tools as well, and we use them in production, we're like, wouldn't it be great if we can share all that with everybody else and just kind of help everyone solve this problem, and we can solve it all together. What happened here? So.
No, your laptop froze. Is what happened.
What?
Keep talking. I'm going to reboot.
Okay. Oh, boy.
That's irrelevant to the conversation, of course.
It must be hardware. Oh, wow. Well, that's really bummer. Okay, so here's how we set up the demo. All right. So this right here represents your data center, okay? There are 10 real machines in here. So let's just pretend this is like your stuff at work, right? So here we're going to show all the stuff that we're deploying, and we're going to do in big data. We're not going to have any slides. I'm not going to sit here and lecture you about stuff. We're just going to show you stuff. And then, really, I hate having a guy lecture me about something. No, we're just going to do it. We're going to show you guys. You guys are going to yell out what you want to see deployed, and we're going to do it. and we're going to do it on bare metal, or we're going to do it on Amazon. So we fired up some things, right? We're doing the cooking show thing. So we actually set up a Hadoop cluster on Amazon here, and once he gets back in, we'll switch over. All right. Is anybody scared by a terminal? Okay, just making sure. Yeah. All right, good. You came to the right place. Okay. All right.
I certainly can do that. I'm just trying to get back to my good old cooking show magic that we had set up.
Yes. So, okay. So, I can't show a browser on there. Okay.
I'm trying to show a browser on there.
All right. Any questions so far? Okay. Guy's like, wow, I came to the wrong talk. 5 minutes in, it's already. What? We're doing it as a cloud, so I don't recommend like just firing off all this stuff on a cloud. Oh, we are doing it on the cloud and on this as well. Yes, yes. So everything we show you here is going to be cloud agnostic. So this is an important feature that we do in Ubuntu. So whether you pick Amazon, Azure, Joyent, HP Cloud, your bare metal, or OpenStack, everything that you see here supports all of those things, including Juju itself, the tool that we're using to show these workloads, just grew Windows support, and we're about to have CentOS support as a community contribution over the next few months as well. So really, anywhere that an Ubuntu server runs, this will run, including things like ARM servers and Power 8, if you're into that fast stuff. Okay, so Marco, what am I looking at?
All right, well, what I'm trying to show you here is not a terminal, unfortunately, but I'll show you the terminal stuff in a second. So this is something we deployed literally about 10 minutes ago while people were filling in. This is just a somewhat typical standard vanilla Hadoop, Apache Hadoop deployment to do some essentially just some data crunching with a very basic big data setup. So we have Hadoop, HDFS master, a name node, yarn master, compute slave, and then a client that we can access in order to run commands against this cluster here. Let me see if I can make this a little easier to read. Can you guys see this okay? Of course not, because it's HTML5, and I'm on a ThinkPad laptop, so there's like a weird red nipple in front of me. It's really throwing me off here.
Do you want me to drive?
Yeah, can you drive your computer?
Yeah.
I'm going to talk about the computer.
Okay, you talk, I drive.
Sorry. So,
see how easy that was? Okay.
So we're using Juju, and what Juju does is it helps define this language of orchestration for us. So what we told Juju is we want to deploy these components, we want these components to communicate with each other, and Juju made sure that we executed our vision of this environment. So we said, I need to do some basic, I want to run Terrastort a couple 100,000 times because that's the typical benchmark. So I know I need an HDFS master for our storage, we need yarn master for everything up, we need our compute slaves, and we need a name node to do our management stuff. And then we have a client that we can access. And we know that these all need to be connected through here because we've all set these components individually through time. What Juju allows us to do when we're doing these big data deployments, what makes it easy for us is when we have this very simple reference architecture, it's very scaled down, it's a couple machines, and we need to go to production, or we need to try something in development, or we need to actually scale up. We can do all that scaling and all that moving around between environments from our local laptops running in just basic containers and virtual machines, which aren't very effective for big data, but can help us model some very basic stuff, to our data center, which we've modeled here in bare metal. Juju does that translation between all of those levels. So I could take what I've modeled here and put it on, we have it on Amazon now, on our bare metal machine and anywhere else. And we can also scale our model. So when we need more compute power, we can just scale out more compute slaves, and then suddenly we have more power to run our map reduces and to run our various
Are we doing
stuff.
that now?
Yeah, let's do that now.
Okay.
So go over to the terminal, because we're done with this manager view.
Yeah.
Oh, this is Firefox. Just open another terminal. I couldn't get Unity to launch, so.
Got it. Okay, so.
Oh, sorry, question. What's, yeah.
Am I allowed to see work methods here?
What?
Work methods. Am I allowed to see methods? Sounds familiar at all.
Oh,
Oh,
Mesos.
oh, sorry.
I just didn't understand what you were saying. Actually, Mesos is one of the things that we're working on, probably the later half of the year. But yes, we very much would like to. do
model
this with
Mesos in here
yes,
as well.
Absolutely.
Yeah.
Yes. Yes.
So we're going to log into the client machine just to
Manager
run.
big data. Hold on.
Yeah.
Manager big data view, and then for this audience, let's actually look at what this looks like. Right? Can you guys read that, or should I?
No, turn your
Yeah.
colors off, man.
Hold on. Oh wow.
That's way better. I'm glad you switched over to that one. Do white on oh, it works too.
How's that?
Oh, suddenly.
Yay.
So this is what I'm talking about when we make things portable. What this is here is this is exactly what we executed to gain our view of the world. It's just a YAML representation of deployment saying that we want these services, HDFS master, name node, yarn master, compute slaves. These are the charms, which is the instructions that Juju uses in order to execute and set up these services. And then these are the various pieces we need to know about it. Here's how they all relate together. If you scroll up a little more, all the configuration options we need to apply against them and how many units of each that we need. So we have 2 slaves, a bunch of single units, everything else, and we can scale with Juju this. But we can apply this definition against anything that Juju knows, and that is clouds, OpenStack, Amazon, Joyent, Azure, HP Cloud, all those clouds, bare metal, as well as any machine that's running SSH. So if you have SSH to the host, you can execute Juju definitions against those machines. So this is our deployment. This is what we ran to get this view on Amazon, and we can run this multiple times over against any environment. Even while we're talking now, it takes about 10 minutes, depending on how long it takes the machines to provision and to actually install Hadoop, the instructions for it. It takes about 10 minutes for this Hadoop deployment. So George, dump out of this. We're going to log in and run a TerraSort. Then we're going to do some scaling, and then we're going to run TerraSort again, and we're going to see how we can easily scale up our infrastructure as we need it.
Question, how do you set, suppose you want to configure parameters, suppose you're using this and you want to do some comparisons to changing buffers and things like that. Where would the parameters be set?
Right, so there's 2 places those are set. Each charm, the definition, of course, for all these code sets, these chunks right here are charms. Each charms expose a level of configuration. We've exposed what we think is people would like to use. You can also expose those as well. If you need to add, you can amend those pretty easily.
I'm actually showing it right here.
Yeah.
Yeah.
No,
No,
great
absolutely
question, yeah.
interrupt us at all times.
There are no slides, there is no talk, we're just showing you guys stuff, and we're hoping we can answer questions you have about this stuff.
Yes.
So we have configuration, charms expose those configurations, so you can modify and amend those, and then if you need to, you can actually SSH into nodes, you can make configuration changes there, and then if you figure out, oh, this is something I need to change permanently in other deployments, you can add those configurations to the charm. You can either fork them, there's code projects, so you can fork them and keep them to yourself, you can contribute them back upstream and have everyone else use those configuration options. So there are ways to illuminate configuration options for services.
Do you use some ERP or Mustache, some type of templates? Or
Not quite. So we use most of our configuration stuff defined in YAML. The code for charms depends on the person writing the charm. So Juju is this level of orchestration. We're doing all the components, the management machines, and how these components talk to each other. The actual underlying code and how the charm does the setup is dependent on the author. So these are just executing Python, but it could be things like, it could be writing Mustache templates, it could be using Docker to set up containers, set the charm. You could be using Puppet and Chef to execute stuff, Ansible, SaltStack, just straight Bash. A lot of charms are just people who take their Bash history and kind of throw it into a script. It all depends on the level of interest of the management for the software project. And that's what charms are, just definitions for setting up these services. So we leave you guys to figure out how you want to set up your services. We're just helping you orchestrate those services with other pieces of your infrastructure.
Okay.
And the portability and scalability.
Now we're SSHing in, and we're going to run a TerraSort, right?
Yeah, so go ahead and
I
SSH
could have
in.
been doing that while you were talking.
I know, why didn't you? So run Juju status first, actually. So this is, we saw the HTML5 canvas. You can also, everything you do in this GUI that we've been looking at, you can also get from the command line. They all share a single WebSocket API, so you can even hook in your own tools to drive Juju as well. But there's all this shared inheritance here. So we have a bunch of machines in Amazon. We also have our services defined if we go a little lower down. All our services, configurations, the units, the scales, everything there. So we're going to SSH into our client machine. So George is going to type Juju SSH client/0. So we have the first unit of our client machine. This definition of the service name and the unit we have deployed. So as we scale services, you need to get to specific ones. It's /1, 0, null, 1, 2, 3, whatever one pops up. And so the Hadoop charm drops a terrasort.sh file into place, so you can just execute it. This will run a terragen, terrasort, does everything you need to. as you're using this stuff, you can drop your own scripts into the charms. You can just log in. You'll have a console. You get the HDFS. You can manage everything you need to from within this client charm here. So we're going to wait for this to run. We'll look, see how long it took, and then we'll add some units, run some more stuff. We can throw other things in the mix, pig, storm, Tez, a bunch of other stuff. So we as Canonical, we're interested in big data a lot. We have a lot of need for it. So we've used a lot of Cassandra internally. If you ever use Ubuntu and you get that little pop-up that's like app port pops up, it's like, oh, something crashed, report this error. It actually doesn't go to dev null. It actually goes to this giant service we have running called Whoopsie Daisy, which is backed by Cassandra. We can actually pull up the web page for it in a minute, but we do a lot of computations against that. We find the most common bugs and errors that pop up are then sorted by all the people who have submitted them, and we focus on that for fixing them in the client. So we actually use those bug reports. Even if it pops up 10 times, if you submit it, it'll show 10 times this happened to this user, and if you have other people having 10, 20 times as well, that'll come up in our error tracker. So we actually do use the reports. We use Cassandra. We do a lot of computations against that to figure out where we should target our engineering resources for reparation. So that actually goes somewhere. It's called Whoopsie Daisy. So we're back here. We are just finished we finished the whole MapReduce job. It completed, where's the time for it? Scroll up a little bit.
Oh.
The gen should be,
Time, it's in...
no, I think it's a little further down actually, sorry.
Oh.
It may actually still be running. There we go. So we spent 441 milliseconds. I guess the biggest one here is 1,896 milliseconds computing partitions, and then we're running the actual map and reduce later on down here. I don't think it actually spits up time for map reduce. I don't remember if it does or not.
I think we run it 3 times, right? So
yes, it's still running. I'm sorry. That's fine.
Cool.
So while this is running, we can show you. So this is one of our kind of reference architectures for Hadoop that we have running.
Someone said Elasticsearch?
Oh yeah, we can deploy Elasticsearch. We can deploy like Elasticsearch and Kibana and a few other things as well. That's the nice thing about Juju is we're not tied to any one particular workload. We model dozens, hundreds, thousands. Anything you can deploy on a machine, you can model in Juju, and you can actually connect to other services. So if you want, you can have Elasticsearch and Cassandra and all these things hooked in for your big data computations, but also use that same Elasticsearch to back your log ingestions using Logstash and Kibana and forwarding. We have monitoring you can plug in on top of your environment. So you can plug in things like Nagios, Zabbix, Ganglia, all on top of your monitoring nodes without having to use different services. So you use one product to deploy your OpenStack, and you use another product to deploy your big data, and then you have all these different products that are doing these specific deployments. We're modeling all of those within Juju to allow you to easily to interconnect and describe your infrastructure.
Question over there.
Yes?
So when you're doing the map reviews, where do you select which set of algorithms, whether you want to use neural networks or vector machines to do this?
So everything's stored in this TerraSort script. If you want to pop it open, terrasort.shell. It's very simple. It's one of we use for our demo purposes, but anything you want to modify for our parameters, you can modify within the script and then rerun to do your different benchmarking. We use this to demonstrate that we actually do have Hadoop running. A lot of people don't believe when we say that we have Hadoop running, so we use this as just a demonstration script. But if you wanted to modify any of the parameters, you can modify this terrasort.shell script. Most of our data scientists we run into have their own collection of scripts they run against their deployed Hadoop, and that's where they have all the parameters and tunings and such stored in there. So this is just a demonstration script
A lot
as
of
far
our
as what
terms
you
are
can run.
designed for you to insert a payload into them and then onto the
Right.
infrastructure.
So our payload is our demo TerraSort script.
Also, charms are open source, so if you want to get the charm and add something like to the installation, you want to do something extra, you can just get the charm. You can add that thing that you want, and you can deploy from your local you can deploy your local repository, or you can even push it somewhere. You can contribute it back if you think that that addition or that removal may be beneficial for the community. You can just all terms are open source, so you can just go ahead modify them as you want, fork them, keep them private, share them with the community.
All right. Oh, sorry.
Sorry. Yes.
Why do you need that Can you open the Terraform?
Yeah, can you go back to the TerraSort script, George?
Sure.
Oh, sorry, what was the question?
Why do you leave 20 seconds?
Oh, that was something that we ran into a weird bug where.
Can you do a for loop for 2 seconds?
Yeah, we could have, we should have. We're lazy, so we didn't. To best describe, I guess, the DevOps methodology, we found that Sleep 20 worked pretty well, but in real life, you probably would do an actual loop to check to make sure everything was ready before you proceeded on to the actual Terra sorting. Yes, I thought we had fixed that, but apparently not. Thank you.
Thank you for paying attention and reading.
Yeah. Notice how quickly we closed the script too. We're like, okay, don't show them that anymore. So we're going to go ahead and add a few more units and scale up. And while we do so, we're happy to talk about other configurations. So this is again just Apache Hadoop deployed in various configurations with the name node, clients, Yarn. We also have various other things. We have some things from Hortonworks model. We have things like Pig and Tez and Storm that we can deploy as well. We have Elasticsearch we're deploying now, Cassandra probably as well. So we'll walk through a couple of others of these examples infrastructures and talk about a bit why Juju gives you a bit of an advantage when you're building your infrastructure. But while we're getting that read up, does anyone have any questions so far? Yes.
I imagine in a lot of organizations you are going to create an infrastructure in a kind of QA or a testing environment, and then you're going to take that, once you're satisfied with it, get it out to production in a kind of a similar way. And some organizations like to, I noticed your the Jenkins shirt on there.
I do, yes.
Like to test drive.
I'm not a Jenkins master, but I like to pretend to be one.
So they'll test those configurations before pushing them out and keep an automated set of tests to make sure that when changes are made, they're not screwing something up. How do you go about doing that with Juju?
That's an awesome question. We actually wrote a tool called Amulet that allows you to, I know these names are fantastic. So what Amulet does, it allows you to define how you want your deployment to look. So you can describe briefly, the Amulet representation as an example, consume this representation in my environment, deploy it, and then Amulet gives you a set of tools that allows you to introspect that environment to make sure it is functioning the way you wish to have it function, and execute different commands against to make sure it's doing exactly what you want. So internally, when we do deployments, we have a tool, another tool that runs on top of Amulet that allows our infrastructure team, so IS, our internal source team, any Ubuntu.com property you go to, we're running with Juju on top of OpenStack that we deployed with Juju, then our workloads are deployed using Juju on top of OpenStack. We actually have a set of the same process where we dev it, we run our test against it, it devs, we go to QA, Jenkins executes the job, sets it up, runs our test against it. If that passes, we then move it into production. We run the test against the production, make sure it stood up, and then we switch it live. So we do have that model in Juju, it's called Amulet, and we have a workflow tool called Mojo as well, which does that kind of move through Jenkins process. Yeah, welcome.
Is this like Test Kitchen?
I'm not familiar with Test Kitchen, is it? Potentially. I'm not familiar with it, I couldn't speak to it. Do you guys know Test Kitchen? We can find out real quickly though. Do you mind explaining briefly? Could you sell me Test Kitchen?
It was kind of like what you were explaining, where it was the testing deployment.
Oh, that's actually a
Step would, do things. It would create Docker containers, and you could make sure that, this particular service came up listening on this port, gives you all those kinds of stuff.
So that sounds very very similar to what Amulet would do for Juju. Yeah, that's essentially what it is then. If that's how you described it, I would say that it is, with my limited knowledge of understanding of Test Kitchen, that's probably what it's like.
Some of this stuff.
A lot of what he's talking about with testing environment is something that can be automated and deployment, like the CM process, we're getting the build out like you described, we're going to test it, we're going to put it into a master, and finally release it to production.
So we do have customers and clients that are consuming Juju that are doing this completely hands-off, automated from code push to production. We give you all of the endpoints to do that. It would be up to you to kind of string how you want to. We generally don't try to influence too much our opinions on what people should do. We give you the tools to achieve them how you'd like to. So Juju's API driven. We have testing harnesses that you can use to verify and validate your deployments. And then you can actually use Juju and drive Juju in different environments, and you can port your environment from one dev to QA, QA to production. a lot of our customers, us as well, we use Jenkins for this job, but you could use whatever kind of CI process you'd like to validate and do that orchestration on top of that.
So we would have to have all the stuff, the scripts with GitHub, when you pull and roll back and everything like that.
Right. So it's for us. It's pretty easy. We just have a was it a push script in GitHub, the post commit script in GitHub that initiates the Jenkins jobs, that pulls everything, does the validation, and starts the whole build process. We found that the build process for us is very different than, say, a lot of our customers, which is very different from probably what you would like to do. But the tools in order to initiate that whole process are all available within Juju, and then you just have to find whatever tool you want to use to run your build and driving process. But all the APIs are there, all the tools that we have for test bedding are all open source and available.
You guys have a deployment that we can pick out those for runs and see how it runs.
We don't, but that would be interesting. We could potentially publish one as a
Yeah.
kind of a reference, but we don't have anything like that currently. We haven't had anyone ask us really.
Or something like that works, right? They have a deployment in the sandbox, and we can run it, and we can see what it's like. We can have all the distributions before it works to give us.
Right. So Juju out of the box will do all that stuff. The whole moving between environments and production stuff that we've been talking about, we don't have any kind of payload or demo this right now, but we could whip something up pretty quickly, I imagine, from what we currently have and publish it. I'll be happy to write a blog after this week about it. Yes.
Yeah, question about how you, first question, do you enforce that the charms are idempotent so you can rerun it, or?
That is my favorite word. That is the best word you could have ever said. So all of our hooks, all the code that's embodied in the charms are idempotent. They have to be. Yes. We enforce idempotency by design, simply because there's no way to guarantee the number of times any event will be executed in the life cycle of a service.
Right.
So, yes.
Doing more sophisticated workloads. So here's a problem we just ran into. What we like to do is do it stage by stage, with the name nodes up, the data nodes up, etc., but have smokes in between each stage. And the other problem we ran into just recently, we brought the data nodes up, and it looked like they were off the services started, but you needed to grep the log files to see if there's any error messages in them. So to do a little more sophistication like that, would that be easy change in your Juju charms?
Well, we wouldn't, so that kind of stuff is, yes, you can model that in a Juju charm, where you want to actually smoke the other service before you create the relation to it, then validate that before I create a relation or before I expose myself as ready, I actually am ready. You can model that in the charms. We do a lot of that currently in these charms. We have the concept of these charms they run is that when you create relations, it says, okay, cool, I have a relation. Do I have everything else I need in order to continue execution? No. It'll wait for another event to trigger. Then it checks itself again. Do I have everything I need in order to proceed with my setup? No. So we have kind of that already in there. If you want to do more specific stuff in checking, you're more than welcome to start implementing that kind of stuff on the charms.
And a related question, so you see something with Puppet where you can code rich relationships. I know I understand this relates to Puppet at its higher level, but the problem is you get this, you don't know what the ordering is. Could you actually produce a workflow? Suppose I want to influence a workflow into a rolling upgrade, or I want to optimize it. A lot of times the problem is if you do stuff and I want to do my package installs in parallel because they don't interfere with each other, but then I want to do my, starting services have to be in order. So do you get a workflow, explicit workflow that you see that then you can modify?
That's a great question. So with the later versions of Juju that we're coming out with, we have this kind of idea of leader election bits and being able to model a bit more how the execution pattern happens in an environment. Right now, we don't really have that. It's kind of the Wild West. You don't know where you are in everything fires asynchronously in environments, but events are handled serially on a single unit. So you'll never have two conflicting events occurring on any one service, but there may be multiple events that are firing at the same time inside your environment. There's no way to really have a defined set of these events need to occur before these events can happen next. Yeah.
Okay, thanks, I answered it.
No, great. Thank you. Did you scale?
I did.
Okay, cool.
So
Any more questions before we move on to a couple more pieces? Yeah.
keep them coming. These are great
Yeah.
questions. Yeah.
When you add the Elasticsearch, does it know where, like, in your cluster, which box has it and stuff like that, or is it?
So Juju knows. Juju knows everything about your environment.
That'd
But
be a great time to talk about the machine view.
yeah, so Juju tracks your environment for you. It knows which services exist on which machines, what is it? It's not region. What's that cool DevOps things where Amazon creates availability zones? That's it. It knows which availability zone services are in. It'll make sure that when you scale services, you don't have all your eggs in one availability zone. So it does all of that provider level management for you. As far as services knowing where other services are, right now Elasticsearch is on its own little island. It's not actually related to anything. There's no kind of implicit service discovery. You do explicit service discovery by telling Juju, connect this service with this service now. So right now Elasticsearch is just there. It's not actually connected to anything, but we can deploy things like Kibana, we can deploy other units onto it, create the relations, and then Juju will share the information with each other and allow you to fire events around that.
Right. So this is actually, if you look at it, Elasticsearch, this is the service view, so we're only looking at the service. But actually, when you look at the machine view, I did deploy a bunch of Elasticsearch. Nodes 7, 8, 9, 10, and 11 are all actually there. So I can Juju SSH Elasticsearch /1/2.
Right, so this is just a very expensive deployment right now,
Yes,
essentially.
I'm spending a lot of money on Amazon right now.
But that's an important distinction. You don't actually see how many, well, you kind of can on this client here, but these are all just this is like your deployment topology, which went away, but we'll come back to that in a second. There it is. So these are basically just your services and how they relate to each other. It doesn't, without actually clicking through and seeing, for instance, Elasticsearch has 5 running units, you don't know how expensive that service box is. It could be 1 unit, it could be 25 units, it could be 10,000 units. So we have tools on the command line and in here. So the machine view shows you each machine and which resources are allocated there. So Juju can do things like, it can model denser deployments, so you can allocate multiple services on a single machine. It exposes some level of containerization. You can deploy services into KVMs and to LexC containers on top of machines as well. We're looking to expand that reach, of course, to how we can leverage other containerization tools within Juju directly. On the command line as well, George just ran it a second ago. But if you remember before, we had that giant, long YAML output of all the services. We have ways to condense that. So here's a view of all of the units that you have deployed, and then the IP addresses and their states and their ports that it exposes. So that's kind of just, there's different ways to view your deployment. So mostly people look at it as a service deployment. They don't care about necessarily which machine is where on what, just how many machines I have, where those machines are pointed to, and how they're being executed in the environment.
And everything is green, so we have way more compute nodes now. I think at least 5 more. So now we can run this again, and this should be way faster.
Theoretically.
Does anyone remember what the first number was?
No, did you log out of the you logged out of the machine
I did.
too? Well, of course it's going to be
idea.
faster. So,
Yeah.
but what makes Juju interesting is we're not defining an explicit connection between services. So, for instance, a lot of deployments and big data deployments require something like a SQL-like server for connection, mostly MySQL. What Juju models great is it could be abstraction of the interfaces in which units connect to each other. So we have several SQL-like services that exist within that can speak the same MySQL protocol. So if you wanted to try a deployment with MySQL, MariaDB, and PerconaDB, you can model all those with Juju and switch those components out as you see fit because they all have abstracted the way that the interface that these services talk on. So Juju allows you to define like, this speaks a MySQL interface, this speaks an HTTP interface, and allows you to do a lot of swapping of services. So if you want to switch out different things like web proxies or caches on top of a web service, you want to switch out underlying technologies for databases or any other things as well. Juju models this as these relations as abstracted service interface connections.
Does that mean, though, so one of the problems you see in Puppet is you have all these different authors, and it's hard for them to kind of agree on the same variable to name port, et cetera.
Exactly.
So is this something where it's kind of tight coupling, where people are writing a database it's almost like a standard where people writing a database have to support this interface? And is this interface something that's being shared, or there's a way to do things in a more ETL-ish way?
No, that's a fantastic question. That's exactly what this aims to do. So when we declare an interface has, it's a very loosely defined bidirectional protocol for metadata about that relation to each other, but allows you to define keys like here's my host name, here's a username and a password and a database to connect to. But that is something that's standard to that relationship. So anyone who creates that interface can then reuse that interface and they'll have to implement those same exact keys. And that's how we get this kind of snap-in rebuilding. So it's forced collaboration by saying that there's a defined standard for these interfaces. So as soon as you create an interface, and it's very easy to create an interface, you define the interface. These are the set of keys that I either need to consume or provide, and then everyone who wants to use that interface can just simply implement it with those keys that you've defined for the protocol for communication. Right. So interface exposes the level of key values that need to be sent on the wire, and those are standard for that interface. So that's how we get that sharing ability where authors don't need to actually have to speak to each other in order to have their component switch into another author's component. Yep.
We really have a different flavor of Linux for our servers and everything. Do you have support for, do you have a package we install on it?
Can you repeat the first part? I missed the first half.
We have other flavors of Linux running.
Okay.
We don't have a GUI back end.
Sure.
So do you have packages which we can install those and we can actually?
So great question. So everything I'm getting caught on myself. Everything we've shown here is Ubuntu Linux. Can you run it on other Linux workloads? We're working on that support. We should have it way before the end, like sometime in October we'll have support for that. But the idea is that depending on how you author the charms. So right now all these charms do like apt-get installs. But if you want to deploy that on CentOS, it's not going to apply very well. But if you use a Puppet manifest or if you use Ansible under the covers to run that, that charm can be ported to any other platform. So we have support for Ubuntu and, believe it or not, Windows right now. So you can deploy with PowerShell Windows workloads. So you could theoretically deploy an Ubuntu web server connected to a SQL server in the same environment, and Juju will allow you to orchestrate those. We're doing things, CentOS I think is the next platform we'll be coming out with support with. That should be coming in 3 months at most. And then from there, it's once we solved it for Windows, we solved it for apps. It's easy to port to Debian. It's easy to port to any other Yum-based system past that. The only real requirement, as long as the image has cloud init support, that's what we use in order to precede our deployments for the cloud images. If it has cloud init support and cloud init knows how to use the package manager for that system, as long as the charm can interact with that system's package manager or whatever architecture you're deploying on, it'll work.
And just about every major distro that runs in the cloud is using cloud init.
Cloud init, exactly, yeah. So that's not too hard of a catch. And then Juju itself will also work on various architectures. We support the standard x86, i386. We also support Power 8, ARM, and
what's left?
I don't know. That's it. Am I missing anything? What? That's Power.
Power 8,
yes.
yeah.
Cool. So we also support the underlying architectures as well, as long as the operating system will. And Ubuntu runs on those architectures. Great question. So did we get a Terra sort?
Oh, we did. I believe we're done.
You need to commit log cache.
Oh, sorry.
What's that?
Yeah.
I don't remember the original number, so we'll have to...
They started with, there were more digits.
So we'll go back in the video and we'll make sure that it was actually run correctly. If it wasn't, you can call us out on Twitter and we'll fix that. But yeah, so we use just a standard Terra sort to benchmark a lot of our deployments. We've deployed a ton of other stuff. I don't know what George has been doing while we're talking.
Connecting boxes. I'm the manager. I'm in the manager view, so I'm acting like the manager. But one thing I do want to talk about here real quick is we're talking. I don't want to make it sound that this is all just about deployment, right? Because automating and deployment and stuff is, people are doing that already. So what it really is the great part is the lifecycle management bit. So Marco, if you want to start to get to that, first things first. Right?
Yeah, so
first let's bring my costs down. Right?
I know, we've run up a lot of money on George's cloud. So that's the great thing about the cloud, right? It's just so ephemeral. So with Juju, you can model this kind of life cycle. So we're going to actually scale down our service. So I don't know what George is doing now, but we're going to remove, there we go. Not Unity, just units.
Oh, come on.
Take it easy there, man. Remember who you work for.
The second I typed. Okay, one.
I don't know. I think that was, I'm just going to call that a George Fat Finger slip.
Which one are we going to kill?
So we're going to scale down our services. So what's great about Juju is when we scale up and scale down services, we've already defined the way our infrastructure looks, how services connect to each other. So when we start scaling services up and scaling them down, Juju just rectifies our view. So all of our calls go to this very small, lightweight orchestration service that exists in the cloud. So when we first started Amazon, we went Juju Bootstrap. And that gives us a little machine that does all of our orchestration. And I'm not sure a lot of you are thinking, oh no, single point of failure. We can also create an HA cluster of orchestration nodes for an environment. So if you want to spend more money or if you have bare metal, you can scale the Bootstrap node to be multiple nodes. But for the time being, we're using one. But we can just simply, we type our commands, we basically instruct the orchestrator how we want our view, and then that continuously works to rectify that view by emitting and pushing events into the cloud, whether that's spinning up new machines or whether it's instructing, pushing data out to the units. So this isn't agentless. It's not as cool as like Ansible out of the box is. but we're not doing things like polling. We're actually emitting events, and we're trying to keep crosstalk between services down to a minimum. So once we initiate a relation, we simply say, you two services can now talk to each other. The services will actually start executing communication directly to each other's agents rather than going through a central focal point. So the orchestrator simply sits there to make sure that it's rectifying your view of the world, and then the units take care of the communication as events occur inside the service. So he's scaled down-ish.
Yep.
So we're just removing services. So Juju will rectify that view. It emits events. You're all going away. The services start working to execute the code that's required to do that.
And
whether
we
it's
can see here, like, we can see what the status is for each node.
so Juju says you're now dying. So the agent itself will start removing itself. It'll execute events to deregister itself from wherever it needs to. If it's part of the HDFS cluster, it'll remove itself there. And then finally, it'll emit back saying, I'm completely done running all the events I need to model this removal. And then Juju will remove the machine from the cloud, and then suddenly we no longer have this expensive 20, I don't know how many units we're running, but X units running. We now have a smaller paradigm. So Juju models the life cycle for the entire environment. And that's what Juju really aims to do, which pairs very nicely with things like big data, where you have to model a lot of running services at once, and a lot of units inside of those services. And to be able to experiment quickly, iterate quickly, and push out to production is something that we aim to solve. One of the things we aim to solve with Juju.
This is where used for development. So we do kind of dev environment, and then we run it to a bug, and then we want another developer to look at it. So what we want to do is be able to power the things off, and power them back on. Is that something that if you power things off, could Juju just power that back on?
So it depends. If you power off the cloud environment, if you go to Amazon console, and you power off a machine, the machine's off, and Juju sees that it's no longer existent in the environment, and it waits for you to rectify the view. So it just says it's an error. This unit was here, and it's no longer here. What should I do? Should I spin up a new unit? Should I do something about that? If you power it back on, the agent will re-enlist itself, say, hey, I'm back, and it'll resume execution. I'm sorry?
It's removed from the inventory?
It's not removed from inventory. It's simply marked as, I think it's marked as agent down. It's like, I no longer can talk to this person. I can't emit events to it anymore. And then you, as a user, can rectify that view. We've had people build automation on top of that, where agents are down for longer than X minutes. It'll spin up a replacement using the API for Juju. But if you turn the agent back on, if you power the machine back on, it'll re-enlist in Juju and resume where it left off. So Juju will just pick up and say, okay, it's back. Here are the events that you missed. Here's their backlog to process now. And it'll queue those events for emission.
And when you're doing this on bare metal, Juju's actually talking to a tool we call MAS, which is Metal as a Service, which does have all that kind of information. So those green lights match the lights on the actual physical servers. So that is available.
Right. I don't know how, I should know what time the talk ends. I don't know what time the talk ends. I don't know. It's too late.
You have 13 minutes.
Okay, great. So
Okay.
we can start looking at a bunch of different things. I know someone mentioned Storm. Do you want to pull the Storm bundle up? We're not going to be able to deploy it we could deploy it in 13 minutes, but
Let me just.
we could just show you what that kind of looks like, how it's modeled. We have this, if you're interested.
Can I just reset the environment?
Sure.
Okay.
It's the worst that could happen. It's only production. No.
No.
So we have, can you open up the Storm one in the Juju GUI?
Oh, sure.
So we have jujucharms.com, which is our sandbox. It's the same GUI you get in production or in Juju environment, but you can actually just drag and drop stuff, and it emulates your environment in a JavaScript kind of emulated Juju environment. And you can actually build your infrastructure as you'd like to see it, export it, and then execute that definition against actual hardware. So if you're interested in what components we have modeled in Juju, jujucharms.com, you can start adding them, snapping them together, defining scale, taking a look at it. I think George is going to open up one of these.
Yeah, just waiting on the GUI.
Well, you just killed the entire environment, so that's not going to come back. That's why I said jujucharms.com. Yeah, that's what happens when you destroy your environment.
Sorry. I know better than that. My bad. All right, so we'll do this on the fake. So what's great about this is I actually like to do this to kind of model what I really want. Then I export from jujucharms.com, and then I run it on my laptop or whatever.
So we can actually do that now real quickly if you want to try while
let's do
Amazon's
it.
going away.
Let's do Storm.
Do you also share so you're building these topologies, is there a store for these topologies, or those are just deployment specific and those are kept internally?
So we actually do model them. Do you have the big data page up?
Yes.
Yeah. So we actually have these published as our kind of like topologies. We have this thing called a charm store. It's not actually a store. You don't actually buy things from it. It's just a central location for all of our charms. And we call these deployment models bundles as well. So there wasn't anything cute that we can think of that matched the whole Juju naming scheme. So they're just bundles. But bundles is that YAML representation. So people are taking the architecture saying, hey, here's something cool we did, and they're publishing it up so people can reuse, reshare, and reproduce. Yes? The closest thing that we came to, so we entered this space 3-4 years ago.
A long time ago.
We've been doing orchestration, we've been trying to model orchestration for a long time, and it's a problem that people are starting to really see as an issue. I think the only thing that we came close to at the time is SCaLE. I'm not sure if you're familiar with SCaLE. It's an Amazon-only orchestration tool where you had this idea where you define services and you execute your service against an environment. That's very similar to what CloudFormations is now. So if you think of CloudFormations on Amazon, there's a similar concept in OpenStack, and other clouds are having this idea where you're defining this item and you're executing against the environment. The real big difference is we're cloud agnostic. So you can run what you want on Amazon, and tomorrow you can turn it off and set up on Azure. You can turn it off tomorrow and then put it up in bare metal. So when we tackled the orchestration issue, we said, this is a real problem for us internally. How do we manage all these services? You can imagine Ubuntu and Canonical run quite a lot of services that we have both internally facing and publicly facing. So this is the tool we built to suit our needs. It works for us at the scale of 10,000, and it works for most people at a scale of 1 machine. So that's kind of the concept we wanted to embody and model in here. I don't think we have anything directly competing with the idea we have now, but SCaLE would be something that's similar, and CloudFormations is something that's also in the same general arena. Yes? Yes, you can run Juju against OpenStack. It won't use the stuff in Heat. Heat is their CloudFormations competitor. So you can't actually consume directly the stuff you model in Heat, but you can replace Heat with Juju. So if you have an OpenStack setup, you can run Juju against it. And then if you want to try that deployment you modeled in Juju somewhere else, the same thing applies. You can just export and re-import somewhere else. But it is essentially a replacement to Heat, but it's not directly in competition with Heat. We're not like, Heat models some other things that we're not modeling, and we're modeling things that Heat isn't taking into consideration. I'm sorry. Well, the main difference is Heat is just OpenStack. And then Heat does some other specific things with managing the OpenStack directly. We do that in Juju, but we do it on 2 different layers. You can deploy OpenStack with Juju on bare metal, and then you can deploy workloads using that same Juju install on top of the OpenStack you manage with bare metal. Heat doesn't do that kind of stuff. There's OOO, which is trying to do OpenStack on OpenStack, which is using Heat at the back end, but there are similar from a front end view. We're achieving similar goals, but we're achieving them in a completely different fashion. Heat doesn't run agents, as an example. We're using agents to emit events. We're modeling events in general for the whole lifecycle service. It's simply Heat's more of a deployment setup where you model your deployment, you execute it, and that's it. There's some differences in how we handle lifecycles of services. Kind of like we go for longer running stuff. Heat does more of a deployment. When you want to upgrade your deployment, you just deploy somewhere else and you repoint everything to it. Yeah, great questions.
This is what an OpenStack bundle does.
As you may know, OpenStack has a lot of components.
Right. So later on at the booth, we'll probably do some live deployments of OpenStack and stuff if people want to see.
Yeah, so if you've ever tried, in addition to your jobs as managing big data installs, if you've ever tried to manage to install OpenStack, we can run OpenStack installs in 15-minute loops in here from 0 to VM. From machines powered off to fully running, ready to create VMs, OpenStack installs under 15 minutes on the box. And that'll work on a scale of 10 machines. It'll work on a scale of data center size. So that's kind of the concept behind Juju. That's how we differ from other components. But great questions so far. Any other questions? I want to make sure we address questions before we just start throwing random paints at the wall. Do you have something you want to export and read?
Yeah. So the big thing I want you guys to think is when you get back, just think of jujucharms.com. There's this button that says "See all the solutions," and you click on that, and it will take you View Solutions, and it'll take you to the big data page, or just Google for big data and Juju. And when you scroll down, this is where you'll see the prefabricated bundles that we kind of call our references. To kind of get you started, right? So these are like the basic Lego kits that we feel are like good ones. Now, if you think that sucks or whatever, make a better one, and then we'll put yours up here.
Yeah.
Is kind of what we're trying to say. So we're kind of like seeding. What we're trying to do is kind of seed that these are the basic Lego blocks. Go build something awesome, and then you get to share it. because in Juju we do enforce separating config from data. So it instantly allows us as an open source company to open source our infrastructure. So when you Juju deploy Elasticsearch, that's exactly how we deploy it. In the real world, using Ansible and all the good bits.
Same thing with Cassandra as well. If you want to know how we manage Cassandra at scale for whoopsie daisy, having tens of thousands of Ubuntu machines phone home when people are issuing errors, which actually, you know what? It's probably not. There's probably like 3 errors that ever occur in a year for Ubuntu, now that I think about it, because it's so perfect. But if we were to have a lot of issues pop up at once, how do we handle that in the back end? How does Cassandra scale for us? We have all of our code that we use to manage Cassandra at scale and make sure it's performant. Not scale to conference, scale at scale, large scale. All of that's inside the code, inside the charm. It's all open source software that we have made published. So please feel free to peer review it. Take a look at it. If something isn't right, you can tell us, you can fix it, you can submit it, and suddenly you'll make the world a better place.
Unfortunately, the gentlemen that wrote these bundles are at Strata instead of here. There was
I know.
conflict. So, but yes, please kick these around. We've already gotten some great feedback on things we can do to make the big top story a little bit better for you guys using Apache Hadoop. So we're definitely receptive to feedback. Are there any more questions? Yes, sir.
So do you have to have open file in the box? So we have custom box stack, OpenStack, I'm sorry.
Yeah.
Do we have to have, I don't even know what an OpenStack is.
So we've got to use Juju with OpenStack or use it with other technologies.
So, I'm sorry, what was the example?
So OpenStack for me is
Yeah.
a way of turning a computer or a couple of computers into a cloud.
For sure.
Distributed. So can we just use Juju with, say, Amazon directly? We don't need OpenStack in there.
No, you don't need OpenStack at all.
Absolutely.
Yeah.
All the things we showed you on Amazon, there was no OpenStack at all.
Because the reason why we're asking is because our company doesn't use OpenStack, doesn't use Amazon, but we have our own kind of distributed computers.
Mm-hmm.
So we want to just use it without any other.
Does it have, I assume it exposes an API?
Yes.
Does it conform to like the Amazon or OpenStack APIs?
I don't know.
So there's a couple of things that's interesting for you. So we actually have native support in Juju for like the big clouds, Azure, Amazon, HP Cloud. We use MAS for OpenStack, MAS for Metal as a Service. If you have your own compute service that you're running and has an API, we actually have written kind of plugins for Juju that run DigitalOcean. There's also another company called Online.net, which is running real ARM servers with a cloud API. You can actually very quickly wrap Juju's API to expose your machine's API service so that Juju knows how to spin up those machines and communicate with those machines and get them rectified. So if you have an API, you can plug it in pretty quickly. Yeah, so if you have to make a REST API call to your web service to initiate stuff, you can outline the credentials you need for that in a YAML file that we use to manage credentials for the cloud, and then you have your code with Python, Bash, whatever you need to, written on top of Juju that leverages and pushes that stuff out. So you can easily ramp up if you have an API. If you use an EC2 compatible API or something else, you can do that as well. But if you have questions about that, find me later, and I'll show you those projects as references so you can get started there.
The reason why we asked is because we work with one project, and the turnaround time for computing power we have is faster than Amazon.
Mm-hmm.
So that's why we don't move to places like Amazon.
Sure.
We have computing power which is much faster period, but it's pricey.
Well, that's fine. Private hardware is usually faster than public cloud hardware anyways. You don't have to compete with most density problems and such as well. So yeah, no, there's ways you can model that deployment. Really what that does is Juju at the end of the day, it needs to be able to SSH into a machine. If it can SSH into a machine, it can run its workloads. And so how you get that machine to turn on an SSH, you can kind of wrap around Juju. So you just say, for instance, for DigitalOcean, you say Juju DigitalOcean Bootstrap that uses the DigitalOcean API to query and pull a machine up. When that machine is available, it comes back, Juju does its Bootstrap process on top of it. So you can do a very similar model. We have like a library we wrote to make that whole transition for people's private clouds very easy. Yeah.
Mm-hmm.
Yeah.
Just quick thing, everything we've shown you here is 100% free software. So if you go to jujuchimes.com, click on community, we have mailing lists, we have IRC network, we heavily use Stack Exchange to answer our users' questions about using this technology, so we really dig that. So yeah, unless there's any more questions, we'll go ahead and wrap it up.
I just wanted to mention that if your company has a product that you want to deploy with Juju, you can write your own Juju charms in any language. So you can keep them private, or you can even do better and submit them to the charm store, so everyone in the world can just deploy your service using Juju. with just a couple commands. So the charm store already has a couple hundred charms. So having even more charms would be beneficial because we're enforcing best practices on how to install and manage the services. So if your company or yourself, you have a service that want to write a charm for, please do and submit it to the charm store. We'll be more than happy to take a look at it.
For example, this is our latest one, fresh. This one landed a few days ago. The MariaDB guys really sat down with us and said, well, you're doing it all wrong. Do it this way. And we're like, okay, show us. So they did, and they published it themselves. So when you deploy this charm, you're getting the latest, freshest stuff from MariaDB itself, using their packages the way they feel the service should run best, right, as opposed to the traditional distribution model. So you can go and you can set up clusters, and it has all that stuff. You can put in your key. This runs on Power8. It's really awesome. So this is just one example, and we're also working with other people like Elasticsearch, Zabbix,
all those guys,
a whole bunch of Nagios, a whole bunch of people to make sure that when you go and you get this stuff, that it's high quality. So
the last thing I want to mention, which is I think quite important that we didn't touch on at all, this whole charm store concept is actually very important to us because unlike a lot of other repositories that host these user-submitted scripts, we actually peer review everything that comes into the store for quality, for sanity, for security purposes. So everything that we publish into the charm store has been tested and verified. It works on all the architectures we support, and then has also been peer reviewed by another coder, at least another coder, to make sure that there's nothing nefarious or crazy or crackpotty in there that would cause potential breakage in production deployments. We're really trying to make sure that when we encapsulate these logics of how to set up services, that we're doing it in a way that's sane and repeatable and reliable for people to do them in production. That's not to say that we shouldn't go and verify that the stuff we have in the charms is there, but there's the extra knowledge knowing that there's at least another person that's looked at this for sanity.
Mm-hmm. So with that, thank you very much. Thank you for coming to my talk. I appreciate all the questions. And we'll be hanging out here for a little while, I guess.